bacterium is problematical. It could be a part of a bacterium. It could be a section of one, but it's biologic in my view.
I'd like to welcome everybody here today. It's an unbelievable day. It's very, very exciting for me.
Finally, in 1996, after more than 2 years of study in which they had built 4 independent lines of evidence, the team was ready. They announced their hypothesis. ALH 84001 contained possible evidence of past life on Mars.
We conclude that this is evidence for early life on Mars.
NASA held a major press conference, but not everyone was convinced. Labs across the globe requested samples of the rock to conduct their own analyses. In the end, after months of, at times, acrimonious debate, the consensus was that there was no consensus. Papers were published in support of the claim, but many more were published debunking the idea.
If I could have the first slide, please. The features that you see may be any number of things. For example, they could...
Many researchers are convinced that the formations in the rock that appear to be signs of Martian life were actually caused by mineral activity.
The majority of people would say that there is no relic biogenic activity in this meteorite from Mars. Dave's initial hypothesis was incorrect. I would say at this point that that's too simple a hypothesis to take. I don't think the work has been completed to a satisfactory endpoint to say either way.
Work on the meteorite is continuing. But even if researchers never confirm that the rock contains signs of Martian life, the ALH 84001 episode has already completely reinvigorated interest in the quest for life on the red planet. Ironically, the new push to find life on Mars has often led scientists yet again to the continent of Antarctica. Conditions in this part of the world are analogous in many ways to conditions on Mars. Seeking out life forms that manage to thrive in extreme circumstances here might shed light on how and where primitive life could have once taken hold on the red planet. One environment astrobiologist Dale Anderson focuses on is at the bottom of lakes, covered year-round with thick layers of ice.
Most people said that because of the thick ice covers, you would find nothing but rocks. There would be very little to nothing on the bottom.
The ice layer sealing off many of these lakes is up to 15 feet thick, but rather than trying to blast or drill through it and disturbing the ecosystem below, Anderson and team have found a much less damaging approach. They let a massive coil of copper tubing make an opening.
Then you just pass a hot liquid through it, throw it out on the ice, and let it melt its way down. It takes about 24 hours. It melts through the ice, and we've got this very nice, clean hole to dive through.
Divers enter the water wearing full-body dry suits. And what they find at the bottom of nearly every Antarctica lakebed is a testament to the stubborn tenacity of life. Mats of microbial organisms are thriving in frigid environments that receive virtually no sunlight.
Most people thought that if you had less than about 1% of the surface light, you wouldn't have any photosynthesis taking place down on the bottom. They wouldn't be able to use enough light to live. It's turned out that they can photosynthesize with light levels down to 1/10 of 1%.
For Anderson and his team, the pristine mats are truly a window to the past.
There are no higher organisms, no fish, no insects, no animals creeping through it. So these microbial communities have the opportunity to grow by themselves without interference from other animals or plants. And that gives them the opportunity to grow in very special ways.
Is it possible that a similar form of microbial life could still reside somewhere beneath the frozen surface of Mars? especially at the hydrogen-rich poles? Anderson and scientists like him believe it is worth investigating.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, engine ignition, and liftoff of the Delta II rocket with the Mars Exploration Rover.
In the summer of 2003, NASA's Jet Propulsion Laboratory delivered 2 exploration spacecraft to the surface of Mars. Missions to the Red Planet are only feasible once every 2 years during a specific short window of time. The launch must be timed so that the spacecraft and Mars arrive at a specific point in the planet's orbit at the same time.
Program response is good.
The journey across the 34 million mile distance can take up to 7 months, and the trajectory must be perfect.
The accuracy required to go from Earth to Mars and to hit the spot you want to be at on Mars is equivalent to shooting a basketball from Los Angeles to New York and have it go through without hitting the rim. Nothing but net.
All systems are go for entry, descent, and landing. We are currently 6 minutes from landing at the Gusev crater in the southern hemisphere of Mars. Current velocity 1,356 miles per hour. Expected parachute deploy in 5 seconds. Parachute was detected. Expected retro rocket ignition on my mark.
The spacecraft were actually rovers, robotic vehicles capable of traveling across the Martian surface and poking around.
The rovers are robot geologists. Their job is to be our eyes, our feet, our hands on the Martian surface. We experience Mars through them. They can reach out and they can touch rocks. There's this device called the RAT, R-A-T, the rock abrasion tool, which is a diamond tip grinding tool that we can use to grind into the interior of a rock, and so we can actually get a window inside the rock. They have sensors on the end of that arm, like there's a microscope, for telling us in detail what they look like. So we've got a whole bunch of tools similar to what a geologist would want if they were actually physically there on the scene.
The rovers were named Spirit and Opportunity, and they are still exploring regions of Mars today at locations on the planet hundreds of miles from each other. Spirit landed in an area dubbed Gusev Crater. The crater is believed to be a dried-up lake bed, so if the water it once held contained biology, Spirit might uncover signs of it. Opportunity touched down in a region called Meridiani Planum. The area is intriguing because it contains an ancient layer of hematite, an iron oxide that on Earth usually forms in a spot that held liquid water. So far, neither rover has found signs of life. But both Spirit and Opportunity have uncovered ample proof that liquid water was once plentiful on the surface of the Red Planet.
We've seen places where water soaked the rocks beneath the surface. We've seen places where water came to the surface and flowed over the Martian surface, creating little ripples that are still preserved in the rocks billions of years later.
But neither rover is close enough to the tundra-like Martian poles to uncover actual frozen H2O. That is the primary goal of a new mission to Mars, launched in the summer of 2007. This mission is dubbed Phoenix, and its plan is to place a stationary lander in the region of the Martian North Pole. The the lander has a sturdy robotic arm equipped with a scoop. Phoenix will excavate the polar soil. Dr. Peter Smith of the University of Arizona had